Recently, the chip industry has attracted much attention. The development of smartphones and computers has largely benefited from breakthroughs in chip technology. The lithography machine is the core equipment for producing chips, and its difficulty in innovation requires the cooperation of several industries. Perhaps many people are unfamiliar with lithography machines, but I can say that lithography machines are of the same magnitude as large airplanes. In terms of price, the current price of ASML's first-generation EUV machine has reached $145 million. The price is equal to the Boeing 737. Because its technology is significantly ahead of its peers, as a manufacturing company, ASML's gross margin can reach 50%. This is a terrifying number. Other manufacturers like General Motors, gross margin is 8%, the gross margin of Volkswagen in 2020 is about 18%. The evolution process of the lithography systems is very complicated, but as a popular science video for the general public, I will describe its principle in a simple way. First principle. Moore's Law. 15 years ago, desktops were big, but the performance is far less than the current smartphones and tablets. Moore is the co-founder of Intel. He proposed that the number of transistors that can be accommodated on an integrated circuit will double approximately every 18 months. This means that the performance of the same size chip will double around every 2 years. Therefore, with the development of science and technology, chip manufacturing has become more and more sophisticated. Today's chips are only a few nanometers apart between two devices. So how small is 5 nanometers? Assuming that the diameter of a hair is 0.05 millimeters, then 5 nanometers means that a hair is divided into 10,000 on average in the axial direction, and the thickness of each hair is about 5 nanometers. How to make such delicate stuff? Generally, if you want to make something small, the core idea is to enlarge it. Usually we use mechanical structure to make delicate things. However, that method is obviously unable to complete the manufacturing process at the nanometer level, so people use light. How to amplify the light? It's very simple, just like the principle of a projector in a classroom or movie theater. The core of the lithography machine is to create an enlarged light-transmitting mold to imprint the desired shape on the mold. And the light passes through the mold to irradiate the silicon wafer, so that a small-sized product can be manufactured. Due to technical limitations, Moore's Law was about to expire a few years ago. But ASML's EUV machines are pushing Moore's Law forward. What is EUV? Generally speaking, the range of visible light is from red to violet. Light outside of red is called infrared, and light outside of violet is called ultraviolet. They are all invisible light. So, UV means ultraviolet, and E stands for extreme. So the full name of EUV is extreme ultraviolet. Why do we use light with a short wavelength? We have to understand another theorem, principle 2. Rayleigh criterion. According to the formula, the size that an optical system can resolve is proportional to the wavelength of light. So if you want to make a smaller size, you have to be able to distinguish smaller sizes, so the wavelength of light must be shorter. ASML has spent nearly 20 years developing EUV. The core is to find a way to make the wavelength shorter. The ASML video marked us with a purple light, but in fact we cannot see this light. At present, the main productivity in the industry uses DUV, deep ultraviolet, light with a wavelength of 193 nanometers as a source. DUV has a high degree of maturity. It can be used in medical treatment, for example, to correct myopia. But the wavelength of DUV is 193 nanometers. Apparently, it cannot meet the needs of modern chip manufacturing. So how to upgrade the technology? This has troubled engineers for a long time. Upgrades in the manufacturing sector generally use existing and mature technologies to improve. Just like Google Pixel has always used the same camera module before, but every year it optimizes the algorithm and makes a great use of a module. This method can also be used in lithography machines. EUV uses the 193 nanometers Dove light source. It can excite the shorter wavelength by using a light pulse to hit the liquid tin. In fact, hitting liquid tin with a light pulse has been verified for a long time. But the products of the light intensity are not always strong enough. Until 2015, scientists came up with a new solution. Guess what? Do it twice. So how to realize it? First pulse, flatten the metal droplets so that the second hit can be expanded. Second pulse can evaporate the droplets to produce a type of plasma. When we create a plasma, the energy will be released in the form of light. The wavelength of the light can fit the standard of the EUV. Well, that sounds easy for me. Wait a second, I'm gonna to tell you how difficult it is to achieve this technique. Metal droplets will fall from the air and are only 30 microns. In other words, the difficulty is the same as hitting a fly twice in the air with a tennis ball. But the duration of light produced by each hit is very short, which requires high frequency with repetitions of 50,000 times. Have you been shocked now? In fact, getting the light source is just the beginning. The light in the video is refracted many times. But EUV light is very easy to absorb, even air can absorb part of it. Therefore, every time light passes through a lens, 30% of the light intensity is lost, only 2% of it reaches the end. The lens in the video is also worth talking about. Lenses are very important to technology. Most people have sometimes been in such situations when shooting videos at night. This is actually the deviation of multiple reflections of light in the lens. It is a normal physical phenomenon. Some manufacturers choose to use lens coating to reduce the impact on video when this phenomenon occurs. However, in the lithography industry, deviations are not allowed, so the process requirements for the lens are extremely strict. The mirror used in the EUV machine only allows 13.5 nanometers of light passing through, and other light will be absorbed. The diameter of the mirror is only 30 centimeters, and the surface is extremely smooth. How smooth is it? If this mirror enlarged to the size of Germany, its surface is only raised by 1 millimeter. This mirror has 40 layers and the interval is only a few nanometers. Whether it has the ability to make extremely fine objects is the criterion for judging the height of a civilization. This may be the smoothest mirror humans have ever made. The final delivery link also maintains the consistent and rigorous style of the chip industry. The various parts will be assembled and tested in the factory before delivery. After that, it will be divided into batches and sent to the destination by plane. After being delivered to the destination, they will be assembled again in the cleanroom of the destination. Our SML's engineering and scientists will also fly to the delivery location for guidance. At the same time, a training center will be set up at the delivery location to train service personnel. Our SML has more than 5,000 suppliers worldwide, and 90% of its components are sourced globally. These suppliers have gathered leaders in various technologies and industries. Zeiss in Germany, ABB in Denmark, Nikon in Japan. In the process of the rise of our SML, we can find that the advancement of lithography machine technology is the result of the joint development and cooperation of outstanding technology or manufacturing companies in all countries. Let's work together to push the industry to break through the technological limits.